start here with arithmetic sequences. It's lesson 2 in the book. And arithmetic, what do we know about arithmetic? We are adding or multiplying. Adding, good. So it's just like your basic patterns from like elementary school. An arithmetic sequence is a sequence in which each term is formed from the preceding term by adding a constant. And that constant can be positive or negative. So if the sequence is increasing, we are adding positives. And if the sequence is decreasing, we're adding negatives. Okay? And each term is determined by adding, we got to do this sequence here. So 7, how do we get from 7 to 10, 10 to 13? Okay, we are adding 3 to the next term, or the previous term. Good. So now they want us to calculate these differences. So what this is doing is setting up the next term, subtract the previous, okay? The next term, subtract the previous. So if you were away yesterday, that's just some general notation. Tn, this is the term value. And then n is the term number. Okay, so if you have, like, in this case, T3 equals 13. Everybody can see that. The third term in the sequence is 13. The third term is 13. Okay, so now we can calculate these differences. What's the second term? Take away the first term. 3. What's the third term? Take away the second term. 3. Okay, and this is just a general pattern that will always happen. Okay. Yep. Okay, so this common difference, okay, they are going to give a specific letter for this, and they're just going to call it, of course, D. That will be the common difference between successive terms. And in this example, it's 3. Okay, so finding the common difference. The common difference is always found by subtracting the term number from the term number previous, which is obvious. You just take a look above. So for example, T5, take away T4. So Tn, what's going to be the term before Tn? Well, that'll be Tn minus 1. Okay? So if n was 7, 7 minus 1 is 6. T7, take away T6. It'll always work out like that. It's the next, take away the previous. So we can jot that in. The next, subtract the previous. And then, you know, if we're doing geometric, rather than subtract, what would we use? If we're doing geometric? Opposite of multiply. Yeah, we would divide. We would take the next term, divide the previous to get that's for geometric. Okay, so you'll have similarities between arithmetic and geometric, but there'll be some subtle differences. So the next sequence, it's like the exact same numbers, but it's just going in the opposite direction. So the common difference here is -3, since, and we'll just pick 10, take away 13 equals -3. Pretty basic, hey? And it is very basic at first. It only gets weird is when you have to find like random term numbers, like really large term numbers where, you know, it's not the first 5 or 6 terms. Okay, for each of the following, determine whether it is arithmetic and find the common difference for those sequences which are arithmetic. Okay, so this one's arithmetic, for sure it is. What's it going up by? Okay, so D equals 2. Is the next one arithmetic? No. What is it? It's geometric. Does anybody know what and they call it the R value. It's similar to the D value. What do they call that? What would the R value be there? 1 over what? Careful. Yeah, 1 over 2. Why is it 1 over 2? Good. The denominators are being scaled by 2, right? So going 2 times 2 is 4, 4 times 2 is 8, and so on. And what's happening to the tops? Staying 1. So it's being multiplied by 1. 1 times 1 times 1 on top, 2 times 2 times on the bottom. Okay, and we don't have to worry about geometric for now. That's a next lesson kind of thing. How about C? I'm thinking it's... So is it arithmetic? Good. Going up by 6. It's increasing sequence. And this one? Why is it geo? Yeah, you can see clearly. But the reason it's not arithmetic is because look at the differences. If the differences are changing, then it can't be arithmetic. So not arithmetic, i.e. probably geometric. In this course anyway. So we don't have to worry about that one. Okay, in an arithmetic sequence, the first term is T1, but sometimes they just call it A. I have no idea why they introduce A. I would just use T1, term 1, it makes sense, but I guess A, first letter of the alphabet. You just need to know it. There's 2 versions. So if you take a look at your formula sheet, they have all these formulas at the top for arithmetic and geometric. They're the same. They're the same formulas. It's just one uses the A notation and one uses the T1 notation. So pick one that you like and stick with it and just stay in the column. Okay, it's not like there's 6. It's not like there's 10 different equations. It's either this column or this column. Clear? Okay. State the values of A and D. Well, A is the first term. So that's pretty easy to spot. First one's -8, the second one's 15. So those are the first terms in each sequence. And now we need to find the common difference. So if you wanted to do it by hand, you would take a term like 12 and subtract the previous. So 12 take away 2 is 10. So here the D is 10. It's going up by positive 10. And for this one, which is decreasing, just take a value, like let's use 5. 5 take away the previous. 5 take away 10 is -5, so that's your D value, -5. And if the D value is negative, sequence decreases. D value positive, sequence increases. Okay, so they want us to investigate how the general term formula is deduced. So we can just work on that here. So let's take a look at this sequence. What's it going up by? 10. And what they do is they write each term in terms of the first term. So what would 12 look like if you had a 2 in there? Well, it would look like 2 times 2 plus 10. And what would 22 look like? Well, it would be 2 plus 2 jumps of 10. So all you're doing is basically how many jumps. So term 4, how many jumps would term 4 have? Yeah, because let's just write it out. 1, 2, 3, 4. This would be like term 1, term 2, term 3, term 4. How many jumps to get to term 4? 3 jumps. So notice in term 4 you have to start at the first term, like you have to have a starting place. So you start at 2 for this sequence, and you would need 3 jumps, and each jump is worth 10. 3 times 10, 30, plus the 2 is 32, and you just get this pattern that's just going to develop forever. And they write it out in terms of if 10 was just written as the D value and 2 was written as the A value, and you get A plus 3D and so on, A plus 4D and so on. And what do you notice the relationship is in each one of these formulas? The coefficient in front of the D value is always 1 less than the term number. So you can formalize that into your formula for Tn. So Tn, the general term number, is always your starting point plus n minus 1 d. So 1 less than n jumps times d. Because each jump is worth d, and you always have n minus 1 jumps. If you want to get to term 6 from the start, you got to do 5 jumps. If you want to get to term 10 from the first, you got to do 9 jumps. So I find that when you kind of understand where the formula comes from, it's easier to just use it. Sometimes you just grab formulas and you use them and you just hope for the best. And that's not always a good strategy because you don't have the conceptual understanding. So these are the two formulas. You can use either one. I would tend to prefer the first because it just makes more sense. I don't know why I need to introduce A. It doesn't really mean anything to me. I would just use T1. Okay. Yep. Nah. Okay, so you have the general arithmetic sequence in the bottom, right here on this page. You start at A, the next one's going to be A plus D, the one after that's A plus 2D, and so on, A plus 3D, and so on, and then you get the general form. So this is the general form, for any term. So that's very powerful. If you wanted to know the 1,000th term, you just plug in n is 1,000. 1,000 take away 1, 999 jumps times d, and you got it. Any questions so far? Okay, now we can actually start to do some math. Class example 4. Okay, consider the sequence. Determine the formula for the general term of the sequence. So let's just start with the formula that you would just jot down from your formula sheet. The first term plus n minus 1 jumps of d. So that's the general form. Now, what do we have values for? What do we know T1 to be? So we can sub that in. And what do we know d to be? What's it going up by? Going up by 5. So what does this formula depend on? Does it depend on A and D? A and D are constant. A and D will always be the same. So what does this formula depend on? N. It depends on n. Whatever you put in for n, you're going to spit out a different number. So formula is dependent on n. Okay, and that formula will always work, and you can of course simplify if you wish. I'll simplify in blue just to show you that it's an optional step. Sometimes on like a multiple choice exam, they won't leave it where I've left it in the black ink. They might make you go to the blue ink. So all we have to do is a little bit of algebra, just distribute that in. We got 5n minus 5, and finish it off 5n minus 11. Any questions on the algebra? It was just a distribution and then a collection of like terms. So the negative 6 and the negative 5 combined for negative 11. And all I did was multiply 5n before that. Now that we have that simplified term, formula, we can solve for the 12th term. So T12, if I wanted to use the black formula, I would just put in 12 minus 1 times 5. So what's 12 minus 1? 11. 11 times 5, 55. 55 minus 6 is 49. And then of course this should work if you do the blue. If I was to use the blue, 5 times 12 minus 11, that's 60 minus 11, which is also 49. So whatever you want to do. I would stick with the black, and I wouldn't do the blue. But I have to show you the blue because sometimes on multiple choice exams, they ask for like a simplified form, and you have to be able to go the extra step. So that is the formula for the general term. So always check if you need to simplify further. Okay, the next one says find the number of terms. So now we're trying to find n here. Find n. Whereas in the previous example, we were trying to find Tn. A little bit different. The previous example, looking for T12, which has a value of 49. Now in this example, they're giving us 117 negative and asking us to find, okay, well, which term number is this? Okay, 3 is number 1, so this is term 1, term 2, term 3, whole bunch of crap in between, and then negative 117. Do you need a formula for this? No, you don't need a formula for this. You could be smarter than the average bear. Here, let me just whip up a calculator. What was the first number? Is 3? What's it going down by? Or is it going up? Going down by what? Subtracting by 4? You guys seemed a bit worried. Yeah, it's subtracting by 4. Okay, so let me show you the calculator again. We start at 3, and then we subtract 4. And then we subtract 4. And then I could just hit enter a bunch of times. Could you count all that up? Yeah. So you could totally just be smart and clever and cheat on the exam, or you can use the formula. Okay? So, like when I was in high school, and if I was stuck in this unit, I would often just like play around with my calculator. But I'll show you the algebra. Okay. Okay, so find the number of terms. First of all, just start with your formula. Always, always, always. And then we can plug in what we always know, which is the starting term and the d value. So we're starting at 3. And the d value, you guys already told me, was negative 4. Yeah, you guys told me that. Okay, so now we try to answer the question. We haven't done anything special. All we've done is wrote down the formula and plugged in a and d. Now we want to find n. So n goes with Tn equals negative 117. So this is a substitution. Okay, so Tn is negative 117. And now you just do a little bit of algebra and you solve for the n value. Okay, and this level of algebra, maybe at first glance you're like, ooh, that looks kind of weird, but this is just your junior high like two-step equation where you have to isolate one variable on the one side and the numbers on the other side. Okay, you guys have been doing that for a long time. Okay, so you have a couple options. You can move the 3 over at the beginning. You can distribute this 4 right off the bat. You just have to be consistent. You can do what you did up here in blue. So why don't we do that? Let's just simplify the right hand side. Make it a little bit nicer. So that negative 4 will come in and it will multiply. Be careful when you're scaling by a negative. What happens? Multiply through by a negative, the signs will change. So n becomes negative 4n and negative 1 becomes positive 4. All that's happened is a distribution. You guys okay with that? Absolutely, you should be okay with that. Now on the right hand side you have a negative 4n and which constant? 3 and 4 make 7, and it's positive over there. Okay? Since you have a negative coefficient on the right, you might as well just put that negative coefficient on the left. And the negative constant on the left should just go to the other side as a positive. And I'm just going to leave that up for a second. Please just internalize that. Make sure that that's okay for you. You need to be able to do this swiftly and accurately, or else this course is just going to crash and burn. You have to be able to solve these linear equations very proficiently. Okay, you're just swapping terms and changing signs. Okay, notice the 7. Did the 7 change signs? Why didn't 7 change signs? Good, it did not switch sides. These other terms, they swap sides. You just alternate the sign. Okay, now we can solve it finally. 117 and 7 makes 124. That looks divisible by 4. Is it 31? Okay, so that means it's 31 terms. Let's bring that back up to the top here. This is term 1, term 2, term 3, comma, 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 dot, 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 comma. This is term 31. If I hit enter a bunch of times on my calculator, 31 times, I would get there. Remember I did that? Same idea. You're just 31 places down the pattern. Okay, the next stuff on this page, they have a weird name for it. It's called arithmetic means. It's basically one of the only problem solving that they can give you for this section. It's got a weird name. I never remember what an arithmetic mean is. It's not important. But you could just memorize the style of this question, and because it'll definitely be on your exam. It's basically like they're going to give you so many terms. They're going to give you like a beginning and an end and a whole bunch, and they're going to tell you how many are in between, and then you just need to figure it out. Okay? So the terms placed between two non-consecutive terms. So that will look like this. Some term, dot, 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 some other term. And that's all that's going to happen. They're going to give you some term, some other stuff in the middle, which you don't know, and then a final term. And that's how you treat it. You treat it like a first term and a last term. So for example, in this sequence, 5 and 20 are like the beginning and the end, and the 10 and 15 are what they're calling these arithmetic means. Okay, so let's try this out. Place 3 arithmetic means between -4 and 8. And 8. So it's like, okay, how many jumps to get to 8? 1, 2, 3. Would you have to do 4 jumps? 1, 2, 3. So it's 4 times something. 4 times something plus that a value. Does that not look like our general term formula? It does, because how many terms are there? T1, T2, T3, T4, T5, right? And it's always 1 less. Remember that? So formally, like the way I did it there, I'm just kind of thinking about it. Like, how would you just solve it if you're just thinking about it? There's no formula involved. Well, I need to do 4 jumps of the d value, okay, plus whatever I started with. So that should say, okay, so let's just use the formula. It would be Tn equals a plus n minus 1 times d. There's 5 terms, so T5, a plus 5 minus 1. We can put in the d. We know what it is. D. Oh no, we don't know what d is. We probably have to solve for that. We know what T5 is, right? T5 is 8. We know what a is, T1, so that's -4. Plus 5 minus 1 is 4 times d. So see how everything just done through the formula? you know, I thought about it for a while and I came up with something that was identical, but if you just go through the formula, you're always going to be safe. And there's nothing to simplify on the right-hand side. You remember how we always distributed before? Well, you don't distribute this. This is just 4D, right? So what should I do with this 4 here? Move it to the other side. Isolate the term involving the variable, right? That's what the teachers would always say when you're in junior high. Too dark. You would isolate the variable, isolate the term involving the variable. So I got to move the 4 over. And they would do something like really junior high style, like drawing a line, add 4, right? 12 equals 4D, stuff like that. Yeah, you got to be able to do this good, or do this well, pardon me. So 3 equals D. You have to be able to solve linear equations well. In this course, we're actually going to show you how to solve degree 2 equations. That's one of the big goals of this course, is solving second degree equations. So see how there's like a power 1 on this equation? Power 1. So those are the junior high. They're called linear equations. And in this course, we're actually going to show you the degree 2, the quadratic equations. All right, so now that we know that D is 3, we just have to add 3 each jump. So I'll just change my color pen. Adding 3, we get -1. Add 3, we get 2. Add 3, you get 5. And there, we've placed our arithmetic means in between. So I like the question because, you know, you get to just sort of understand what's happening with the sequence. What it's called and what it's the name, like I don't could care less about the name. But I like it because it helps us to understand. Any questions so far? All right. Well, let's just keep flying then. Okay, these are good. They have more algebra practice. And like you're going to be like, well, when will I ever need to do a question like this in my real life or stuff like this? But that's not the point of this course. The point of this course is to practice your algebra and introduce you to ideas that are used in post-secondary. So sequences, like I said yesterday, they're used lots in computer sciences, and here we have an algebra example. So it's just basically like, can you apply algebra to some new idea? And one of the telltale signs of whether you can, if you can make it in university, is if you can understand algebra. So if you can understand algebra in high school and you can get it, then you have a good chance in post-secondary, okay? So it's a good sign. If you really struggle with algebra, even by the time like grade 12 is finished, unless like you're super confident that you want to go to university and take like a science program, like if you're good at algebra, then do that. But like lots of times people choose a science program when it's really not for them. It's really competitive, and so algebra is a good way to tell if you're ready for it. All right, so you have this sequence in terms of x. The first term is x plus 2. The second term, so this is like t1. You can put a little line there, comma. This one's t2, comma, and this one's t3. So those are the terms. And they're given in terms of x. So we want to figure out what the heck x is, and then we want to form the sequence. So if I just gave you numbers, how would you find the d value? If I just gave you numbers, what would you do to find the difference? You would take the next term and subtract the previous. Okay, so let's just do that with the first two terms. 3x, take away 1. That's the second term, right? And we will subtract which one? T1, good. And we can write that formally up here. All we did was T2 take away T1. And what do we know that should be equal to? What's that going to be the same as? Very nice. T3 take away T2. Because no matter where you are in the sequence, that d value will be consistent as long as you have a term take away the previous. So we can write an equation now all in terms of x, and solve for it. So like why I brought that up about the algebra is like you're taking an idea and you're applying symbols to it, and then you're able to follow through and actually execute that. If you can do that, then you know you're doing well. Like if you want to be a doctor, you have to take calculus. Like, why does a doctor need calculus? Tell me. Why would a doctor need calculus? It doesn't make sense. A doctor should do biology and chemistry, right? But it's just the way that like society, like it's like a tryout. Like you have to like beat your competitor to the school. They only accept so many people, so apparently you have to do really well in calculus to become a doctor. Like, okay, so that's all I was talking about there. Okay, so let's do this question. Sorry? Did I write it down wrong? Thank you, Aaron. You copied it? Okay, T3 takeaway 2, 2. There we go. Alright, so now when you do this second step, you have to be super careful. This is a common mistake for students. When you subtract, and you subtract an entire parentheses, an entire bracket, the subtract has to go on each term. It's like you're distributing a negative. Okay? So on the left-hand side, 3x minus 1, take away x, take away 2. The right-hand side, 2x plus 1, take away 3x plus 2. And I'm just going to circle that one because even though you know what you're doing, this one might be a common slip where you miss the minus minus for plus. Now we just collect like terms. On the left-hand side, we have a 2x and a minus 3. What did I screw up? Better? Thank you. I need more coffee. Okay, now on the right-hand side, collecting like terms again, a 2 and a minus 3. And then a plus 1 and a plus 1 like you fixed for me, plus 2. Put all the x on one side, put all the number on the other side. So let's just move that x over. So on the left will be 3x, and on the right will be 5. If that's too fast for you, just tell me. But I kind of need it to be fast. And then finish it off. What's x? 5/3. Good. Okay. Okay, now we need to determine the numerical value of the 3 terms. So the first term is x plus 2, so 5/3 plus 2. And then the second term is 3x minus 1, so 3 times 5/3 minus 1. And then 2x plus 1 will be 2 times 5/3 plus 1. And there's no problem with using a graphing calculator for these fraction operations. I would just recommend using brackets. So I'll show you the first one, the 5/3 plus 2. Like, you don't have to do all that stuff by hand if it's not something you want. 5/3 in a bracket plus 2, and then math fraction if you want to keep it as a fraction. Okay? So that first term was 11/3. The second term, the 3's actually cancel, so it's nice. 5 take away 1 is 4. And the last one, 2x plus 1. So we have 2 times 5, which is 10. 10 thirds plus 1. 10 over 3 plus 3 over 3. 13 thirds. Again, you could do it on your calculator if that's what you want. Move it to the left. Good. Okay, so then it says here the next two examples show two different ways of solving the same problem, where class example 8 uses arithmetic means and class example 9 uses a system of equations. Okay, so it looks like the exact same problem done two different ways. Okay. All right. So the third and eighth terms of a sequence are 12 and negative 18. So T1, T2, T3 is 12, T4, T5, T6, T7, and then T8 is negative 18. Okay, so we're going to use arithmetic means, which basically means, if you recall, we have to just allow like 12 to be the first and 18 to be the last. So this would be like A, and then it would be, I'm going to just change color pen. This would be like A, T2, dot, dot, dot. We've got T3, T4, T5, and this would be T6. So we just do a general formula for 6 terms where the starting term is 12. Okay, so let A equal 12 and T6 equal negative 18. And then you guys, how about right now, just go ahead, use your formula and figure out the value for D. Okay? Do that for me right now. Carl, you cheating. You're supposed to do it yourself. Make it bigger? Why do you have to try yourself? Better? Maybe sit near the front next time. Okay, so if you're done now, you can double check with mine. You just use the general term formula. You know what the A and D are, or pardon me, you know what the A and the final term are. That allows you to plug in and solve for D. And they want the fifth term. They want the fifth term of the original sequence. So it goes blank, blank, 12, blank, blank. And we're subtracting 6 each time. So 6 and then 0. So T5 in the original sequence is 0. Any questions on that? Okay, well, if there's no questions, we'll move on. This next formula that they have up there, does that remind you of anything you've seen before? This formula here from Math 10. Louder? Yeah. This is y2 take away y1 over x2 take away x1. That's a formula for slope. So you can also solve for the slope, which is your constant change, which is your d value. The d value is just the slope. So you could also, instead of arithmetic means, you could actually just use the slope formula, which is interesting. So T8 is negative 18, and T3 is 12. So what was the change in the term numbers divided by the change in the, or pardon me, what was the change in the values of the term numbers divided by the change in the term numbers? So what it does is it figures out the change per term number, which is like a rate of change, which is like slope negative 30. No, that's not negative 30. It is? Over. Oh, I put a 5 there for some reason. Losing my mind. That's a 3. Typo. So 30 over 5, negative 6. So it's the exact same determination. You still get a d value of negative 6. So it's just another way. Don't worry about D. It's all good. Okay, so just we'll put for E, we'll just put think slope, just to remind you if you're studying later. Think slope, y2 minus y1 over x2 minus x1. What you get here is a formula for D. So let's say it was like TB, take away T, actually let's use, I don't want to use A because A is used, TC, take away TB, all over C minus B. It's just like slope. It's kind of like some f at x, take away another f at x, all over x, take away the other x. It's just a slope formula. Okay, and now we'll do the next question, which is identical. Identical question, except we're just going to use a system of equations, which was the last unit in Math 10. So it might be fresh, might not be, I'm not sure. But we have the third and the eighth terms. So let's do T3. So it'll be A plus 3 minus 1D and T8. A plus 8 minus 1D. So that's if you just, copied it down exactly from the formula sheet. We can substitute in those values for T3 and T8 respectively. So we have 12 equals A plus, simplifying for 2D, And negative 18 equals a plus 7d. Any questions on that system? You basically have two equations and two unknowns, which is what we did in Math 10 for systems of equations. Do you remember those? It was always like a y and an x, and you had to, if you knew x, you'd solve for y and vice versa, or you could do a substitution or an elimination. This would be really easy to eliminate y, because they both have 1a, right? They both have 1a. So if we subtract, where does that a go? It disappears. And then you only have an equation with one variable, and that's doable. An equation with one variable is very, very much solvable. So what's 12 take away negative 18? 30. A take away a, 0. 2 take away 7, negative 5. Now we can divide out negative 5 and get negative 6 for the value for d. So that is a recall for Math 10, system of equations. And then now we can solve for the fifth term just like we did before. Or why don't we just use the formula? T5 equals a plus n minus 1d, so 5 minus 1d. So we do need the a value. So why don't we just use the system to find the a value? We already know that d is 6, so I'll just plug it back in. I'll plug it back into the first. 12 equals a plus 2 times negative 6. 12 equals a minus 12. Move that 12 over, you get 24. So a is 24. That's just solving the system completely. Now I can just go and plug into my formula over here. 24 plus 4d, which is negative 6. 24 minus 24 is 0. I think I would go with the means, arithmetic means, if I was you. But there's another option for you, the system of equations. Okay, so since you have the whole weekend, I'm just going to make you do all this assignment. If you want to skip like 1 or 2 questions here or there, I'm sure it's not going to kill you. But I would recommend you do all of this assignment too. There's 20 questions. I bet you could get half of it done before the end of class. And then you got like 3 days to finish a whole bunch. Okay, so assignment 2 all. And if you were away yesterday, don't forget about assignment 1. If you have questions, you can come up to the front. I'll help you. What time are you guys out of here? (1:27). Yeah, so I guess you have all of your East block to finish this.